you cannot say that there will not be any limit. The actual definition of the natural number is 0 to infinity. Okay, but when you implement, it will have some max. So that max number we call it as int underscore max on the particular computer where you are implementing. So first, what we are doing, we are just if you go back to the previous slide, the specification includes what? Function description. First, we are describing what is meant by an abstract data type. So this is how it is described. An ordered subrange of integers starting from 0 and ending with a maximum integer on the typical computer. And then what are the functions it supports? Okay, it supports these functions. And this is some preliminary we are writing for that. For all x comma y, okay, if for all x comma y, if x comma y belongs to NAT underscore number, which is nothing but natural number, okay, then and true or false belong to Boolean. So these are some of the things we are declaring. That is, if say that there are two numbers x1 y which belongs to natural number, and true or false belongs to Boolean, and plus, minus, less than and equal to are the operations that we can perform. Then assuming that these are the functions, these are the typical functions this particular abstract data type may support. Okay, so what is the first function? 0. So this 0 is the name of a function. Okay, this function will return the natural number 0. Okay, it will return the natural number 0. So what it will return, its return type is one natural number. So NAT underscore NO, that is the return type. Its return number, it's the natural number. Okay, there is another function is 0 of x. This returns a Boolean value. So what this function will do, it will check whether x is if x is 0 or not. If x is not 0, then it will return false. Okay, so if you say just if x means, then it means that x is a positive number. Okay, so if x is true, then it will return false because it is not 0. Else it will return true because it is 0. So it is used to check whether x is 0 or not. Okay, and this function add x comma y, it will add two natural numbers and it will return. But before adding, it will check, it will ensure that the sum is not exceeding int underscore max, because this is the highest natural number you can specify. So your sum cannot go beyond int underscore max. So what this function will do, it will check, it will perform x plus y. If x plus y is less than or equal to int underscore max, it will return x plus y. Otherwise, it will return int underscore max, which is the maximum or the highest natural number. Okay, so it returns a natural number. Equals x comma y, it checks whether two natural numbers are equal or not. If x is equal to y, it returns true, otherwise it returns false. Successor of x, it will return the natural number which comes after x. Okay, so here also it will check if x is equal to int underscore max, the maximum, the highest natural number, then it cannot return any successor. In that case, it will just return x. Otherwise, it will return x plus 1. So it checks if x is equal to int underscore max, it returns x. Otherwise, it returns x plus 1. Then what you call subtract x comma y. So this is used to subtract. This is used to subtract y from x. Okay, so that is we want to perform x minus y. Okay, so we don't want to perform, and you can perform this only if y is greater than x. Okay, you can perform this only if y is greater than x. If y is less than x, sorry, you can perform this only if x is greater than y. Okay, you can perform this only if x is greater than y. Okay, if x is less than y, then what will happen? If x is less than y, then it will become a negative number, and natural number starts at 0. Okay, so you cannot return a negative number. So suppose if x is less than y, then it will return 0. Okay, so x should be greater than y. So it checks whether x is less than y. If x less than y, it returns 0. Otherwise, it returns x minus y. So the return type is natural number. Okay, so this is so this is the end natural number. So this is how the abstract data type is defined. Okay. So the abstract data type is not an implementation. It is not, it is, here we are not implementing the data type in any language. It is the specification. This is how this particular data type is expected to behave in any programming language. It may be C or Java or Python or wherever it may be. Okay. These functions may differ. Okay. It is not that every programming language will implement the same functions. No, the functions may differ because in implementation, obviously there will be some changes. Okay. So with this example, I think you got some clarity about abstract data type. Okay. So abstract data type is the one uh, which separates the specification of the data type and the operations from the implementation of the data type and its operation. Okay. So why it is important in the sense a user is more bothered only about the specification. He is not bothered about the implementation. So when you are learning the course lecture, it is a generic course. It is not connected with any specific programming language, right? We are learning it through C, but data structure is a generic concept. So we are discussing something called as abstract data type. So whenever we discuss any data types or any new concepts, we'll start with that abstract data type of that particular data type, right? So that is what I wanted to give an introduction on that. So I want you to try these things as homework. Add the following operations on natural number abstract data type. Predecessor is greater, multiply and divide. Okay, that is abstract data type has some functions, but to these you should add these functions also. Predecessor of x, which will return the predecessor of x. Okay, but before returning, you should check whether x is not 0. If x is 0, just return 0. Okay, and if x is greater than 0, then you can subtract 1 and return. Okay? Then is greater, used to check whether x is greater than y or not. Multiply, to multiply x comma y. Divide, to divide x comma y. So you have to write that appropriate functions and the logic like this. Okay. And then create an abstract data type called set. So set is a normal thing which you might have studied in maths or discrete mathematics. Okay, the set of numbers, right, or whatever it may be. You can define a set and you can include operations to create a set. Okay, create any. So you may include a function create that will create an empty set, right? And then you can use insert some values, which is used to insert one value. Okay, and then you can write functions to remove. So insert, you may use some condition, because before inserting you have to check whether that value is already there or not. If it is not there, you insert. Remove, you check whether the value is there or not. If it is there, remove. Is in, it will just check whether that particular value is in the set or not. If it is there, it will return true, otherwise it will return false. Union, to combine two sets. Intersection, so if you have two sets, combine by using the function union. So provide the abstract specification for the union function. Provide the abstract specification for intersection function. Provide the abstract specification for difference function. Okay. Similarly, create an abstract data type called bag. What is bag? Bag is similar to set, but it can have duplicate values. That's the only difference. Set cannot have duplicate values. Bag can have duplicate values, and include at least these operations. Of course, you can include all the operations that is applicable to set, but minimum you should try these: create, insert, remove, and is in. Then create an abstract data type called Boolean and include the operations and, or, not, and XOR. So I want you to try this uh, by specifying the abstract data type. So whatever you write, it should be of this nature, like how we defined here abstract data type. We have discussed an example abstract data type for natural number. Similarly, you should give the specification abstract data type for set, bag, and Boolean. Okay. So first you have to give the description, okay, the function description, what it will do, and then the various functions. Fine. So please try it and update me. So So let us stop here for this session.